Hello and welcome to the second video in the Getting to Grips with Monero series. In this video we'll be developing our understanding of nodes, the most important piece of infrastructure in the Monero ecosystem. We'll be discussing what they are, why they're important, and demonstrating step by step how to set up your own. So let's get going. Fundamentally, a Monero node is a piece of hardware connected to the internet which both stores a copy of the blockchain and runs the Monero software. Running your own node and connecting to the P2P network is kind of like downloading and seeding a torrent for all those who want to access it. Nodes are programmed to follow a certain set of rules which facilitate the running of the network. An important abstraction from these rules is the consensus mechanism. It's through this mechanism that the legitimate history of the Monero blockchain is maintained. The greater the number of nodes in the network, the more resilient it is against both denial of service attacks and network partitioning. Nodes are typically separated into two categories, local and remote. Local nodes are those within your network, while remote nodes are those outside of it. There are a few benefits to running a local node, the most notable of which is privacy. When you connect to remote nodes, it's possible for the host to obtain the following details about you: your IP address, the block height from which your wallet started synchronization, and the transaction IDs you broadcast, and a list of decoys. Depending on your privacy concerns, this might not be ideal, so make sure you connect to a remote node hosted by someone you can trust. This is quite important. If you're unable to run your own node for whatever reason, you can skip over this video for now. Another thing to think about, either when connecting to remote nodes or hosting your own, is that your internet service provider will be able to recognize all of your activities. Although this information doesn't de-anonymize your Monero address or transactions, it can still be used by malicious actors. Hosting your own node for use with your own wallet simply reduces the amount of your personal data floating around the web. Monero's Dandelion++ technology does the hard part by seamlessly obfuscating the origin of all transactions. This article from the good folks at Local Monero goes into more detail about Dandelion++. Before we continue, you need to learn about whatever local risks, if any, are associated with hosting your own node. This is important for your personal security and obviously depends on where in the world you live and work. Currently, the best ways to shield your internet activities from malicious actors is through either a trustworthy VPN, Tor routing, or I2P. Best practices are not timeless and there will always be developments in the web and the Monero ecosystem, but the Monero developer community is one of the largest and most privacy-focused organizations in this space. Please skip to the next video if you have any security concerns. If you still want to host your own node and support the network, we will of course be showing you how to do so with a VPN in video 4 of this series, using Monero with enhanced privacy. Running your node 24/7 is of most benefit to the Monero network, and for most it's not practical or environmentally friendly to run nodes on powerful and inefficient machines. It's for this reason we'd recommend the use of low-powered, efficient architecture like the system-on-a-chip designs from AMD and Intel. Generally speaking, the Raspberry Pi and other ARM-based systems would be ideal for something like this. However, it's in fact not the best platform for running the Monero daemon. This is because the hardware lacks support for the advanced encryption standard instruction set. The major disadvantage is drastically longer sync times. Typically, only systems with x86 architecture will benefit from this instruction set. The Monero daemon requires 1 to 2 GB of memory to run, so aim to use a system with at least 4 GB of memory. If you're planning on using a single board computer like the Raspberry Pi and are feeling adventurous, we'd recommend this guide published by the good folk from the Monero Ecosystem Workgroup. Be aware that there may be a more up-to-date version when you watch this video. The software required to run a node can be found on the official GitHub repository, the link for which can be found in the video description. If you followed all of the steps from our other video, importing public keys and verifying hashes, you should have already downloaded and verified these files. If you haven't, please make sure you do that now. You'll find it in the playlist labeled Getting to Grips with Monero. The next sections will cover the process for Linux and Windows independently. Please use the timestamps below to get to the part that suits you. If you're using a Linux distro like I am currently, then you're going to need to open a command line terminal. I'm going to navigate to the right directory using the change directory command, cd. You can then use ls to check you're in the right place. If you're using the File Explorer, head to the proper folder and right-click and select Open in Terminal. You'll find the commands used in the description below. Feel free to copy and paste them into your terminal window. To paste into the terminal window, you'll need to use Ctrl-Shift-C and Ctrl-Shift-V. We'll be using the following command for the next step. Let's break this down. First, we're making a directory called monerod in the user's directory. Then we're using the tar function to unpack the compressed folder into the directory we just created. Now let's run that by hitting enter. Use the cd command and navigate to the newly created directory and look for the extracted folder using the ls command. The first thing we're going to do is move the downloaded file to a custom folder. First select and cut using Ctrl-X. Next we'll go to the C drive to create a folder called monerod. Double-click on the new folder and paste the zip file you just cut with Ctrl-V. Double-click the zip file to open, then drag and drop the folder into the address bar onto the name of the parent folder. Open the monerod folder when finished. As Windows users, it's best to add a custom security rule to your virus and threat protection settings to avoid any complications when running your node. First, open the virus and threat protection settings by typing in the search bar or opening the start menu and typing in virus. Next, under virus and threat protection settings, click on Manage Settings. Scroll down until you see the exclusion section and choose Add or Remove Exclusions. Click Add an Exclusion. Choose Folder. Then select the folder that you've just created in the root directory. Creating a config file is a pretty simple way to tailor the Monero daemon to suit your own needs and circumstances. There's no default config file, so we'll be doing this from scratch using the documents hosted on monerodocs.org as a reference. In the monerod folder, create a file called bitmonero.conf. This can be created, opened, and edited with any text editor, so we won't be covering OS-specific details here. We're going to use the example file from the Monero docs website as a template to work from. Please click on the subheading Examples and copy the example to your clipboard using the provided button. Now paste it into your text editor. You'll notice quite a few hash symbols in this text. These are comments. Every time the Monero daemon comes across one, it ignores it and skips to the next line. It's a really easy way for us to leave information and comments in the file without them interfering with its operation. There are lots of different settings you can apply to the daemon, and the Monero docs webpage is a great resource for finding the things you want. The first option we see here enables us to set the location of the blockchain. This requires a little thought because the database that contains the Monero blockchain is rather large and ever growing. One of the prerequisites for this video was at least 50 gigabytes of disk space. This is the minimum required space and would only allow you to download a pruned version of the blockchain, not the entire thing. Simply put, a pruned node is one with the entire transaction history, but only a small share of the details. Not all pruned nodes are created equal, only together can they preserve the whole blockchain, as each holds about 1/8 of the required detail. Pruned nodes are always recommended over using remote ones. However, if you have the space, it's a big help for the network if you host a full node. A full node would require around 130 gigabytes currently, but this size is always increasing. To set the location of the blockchain, you need to edit everything after the equals sign. Make sure you include the full directory path, including the drive letter if you're using Windows. I'm going to leave it as default for now. If you want to download a pruned copy of the blockchain, we need to add a few more lines. First, I'm going to add a subheading starting with hash called custom. This way I remember that I add the following lines myself. Underneath, we're going to add sync-pruned-blocks equals 1 and prune-blockchain equals 1. The value 1 indicates we want to enable this option. If you want to disable them, you can either add a hash to the start of the line to comment it out, or change 1 to 0. Before we take a look at the rest of the file, we're going to add 2 more lines to our custom list. Enable-dns-blocklist equals 1 and no-zmq equals 1. Enabling the block list prevents connections to known bad actors and is centrally maintained by the Monero core team. The no-zmq option disables a particular interface we will not be using, limiting the potential attack surface. Let's move on to the default config. The first setting here sets the location of the database, which will be created to store the blockchain data. I'm going to set it so that it saves it to a new folder called Data within the Monero.d folder we created earlier. To do this, we can simply replace this location with Data. The next thing on the list is the location we want the Monero daemon to save logs. I'm going to change this to the same data folder by replacing everything that comes before monerod.log with data/logs/. If anything goes wrong, we can quickly and easily investigate from here. Before continuing, let's consider what's actually going on here when the node is spinning up. Every time you start the Monero daemon, it starts several processes which use different ports to run, one of which is the P2P service. This is how your node communicates with the rest of the network and keeps itself up to date. Currently, the IP address is bound to 0000. This is the best option if you haven't got any kind of custom networking. The port number is bound to the default recommendation. You can of course change this to whatever you like, but be mindful that a wide variety of ports are used by other applications or services, so it's a good idea to stick to the recommended ones. Being able to change this port number is great if you can't forward a certain port on your router, or if your VPN service requires a certain value. However, for now, leave this port as default. For our node to be a fully fledged member of the Monero network, we need to forward this port on both our firewall and router, so that our node can shake hands with other nodes. The other process on the list is the Monero RPC, or Remote Procedure Call. RPC is the method used for communication between wallets and nodes. We're not going to go into too much detail in this video, but it is possible for you to allow external connections. Running an RPC service is certainly helpful for those who don't run their own node, but it exposes an entirely different part of the Monero codebase to the internet. As many of you will be setting this up on your own personal computer, we advise against this for now. To save time in this video, we're going to skip over the next 2 sections in the config file. If you're interested in what they do, please check out Monero docs for more info. Finally, we move on to network traffic. How many peers you connect to and the bandwidth you allocate is totally customizable. Increasing the out peers and the down rate will directly contribute to your initial sync. I suggest you have these pretty high to begin with. You can always change things later on to suit your circumstances. I'm going to leave all of this as default for now. The next thing we're going to want to do is change the location of the Monero.d program. You can do this through the File Explorer or Terminal, it's up to you. You need to be sure that either the Monero.d binary or monerod.exe is now located in the Monero.d folder alongside the config. Each time you download an updated copy of the software, you'll need to replace this file. After all our work, we can start our node for the very first time. Using the terminal, navigate to the folder that the Monero.d program is located in. Then, for Windows, shift right-click, open up a PowerShell, and type the following command. For Linux, right-click, open a terminal, and type this command. Now let's hit enter. As you can see from the messages, we're now syncing the blockchain to our computer. This is a pretty lengthy process, so be prepared. You can take a break from it whenever you like by using the command Ctrl+C to cancel the operation. To start it again from where you left off, simply follow the same process. Currently, we're only leeching the blockchain from the P2P network, and sharing is caring after all, so we'll want to enable seeding as well. To do this, we're going to have to set special rules in the firewall to allow incoming connections for the P2P port on both our computers and routers. This may or may not be technically possible for you. This will all depend on your ISP and administrative access to your router. The following two sections will cover Linux and Windows independently, so please head to the appropriate section. As for routers, please take a look at our manufacturer's recommendations. If you're currently using a VPN, please take a look at our video using Monero with enhanced privacy, as things will be a little bit different for you. Forwarding the required port is relatively simple as a Linux user. To do so, we're going to use the uncomplicated firewall, or UFW for short. This may be entirely new to you, and if it is, you'll first want to see if it's installed. Open up a new terminal and enter UFW-version. If you don't get a printout with a version number, you'll need to install it, which you can do via your package manager. Now let's enter these three commands. With this command, we're going to enable the UFW, then block incoming connections, and finally allow all outgoing connections. The current state of our firewall isn't ideal right now, as we won't be able to use our browsers or download system updates. For this reason, we're going to want to allow ports 443 and 80. To do this, we're going to run the following commands. Now that the UFW has been enabled and your firewall has been hardened, your computer is a little more secure, and we're ready to make an exception for the Monero daemon. This command will allow traffic to access your Monero daemon. You may remember this port number from the config file we created earlier. After you press enter, you should see rule added. To double check that it worked, you can run sudo UFW status. We can see it listed in the printout, so everything went fine. Well, that's all there is to it for your PC. The only thing left to do is forward the port on your router. Every router is different, so please have a look at your manufacturer's instructions for this step. To begin, click on the Windows Start menu and type Firewall. Click on the result from Windows Defender. Once open, head to Advanced Settings and choose Inbound Rules in the left-hand column. Next, select New Rule under the Actions subheading. Here we need to select Port and then Next. The protocol we're interested in is TCP, and now we need to specify the port used by the Monero daemon, which is 18080. In the next menu, we want to select Allow the connection. Now it's time to name the rule Monero.d P2P before clicking the Finish button. That's it, we've opened up our port in Windows for the Monero daemon to communicate with the rest of the network. The only thing left to do is forward the port on your router. Every router is different, so please have a look at your manufacturer's instructions for this step. On a 100 megabit connection and writing to an SSD, it's taken me a little over a day to sync the entire blockchain. Once it's synced, you should see the message synchronized, OK. We can confirm the status of our nodes by using the command status. This shows the height of the blockchain and a few other bits, including the number of incoming and outgoing connections. You'll notice that I currently have no in connections. This is because I've not yet forwarded this port on my router. Another neat command is print-net-stats, which lets us see how much data has been received and contributed to the network and at what rate. Of course, no internet connection is the same, and you may want to limit your traffic. You can do so on the fly or by editing the config file we set up earlier. It may take some time for you to find the settings that really suit you. If you're interested in seeing what else you can do whilst the daemon is running, type help. As the initial sync is complete, I'm going to limit my traffic. I'm going to offer 1 megabyte a second to my incoming connections and 1.5 megabytes a second to outgoing, as I use my PC for many other things. I'm going to do so using the commands limit up and limit down. Once again, please take a look at Monero docs for more documentation. It has lots of useful information and will help you to tune your node. Well, there we have it, our very own node. Now we can rest easy knowing that we're supporting the network and have the basis for all our future Monero needs. If you have any comments or questions, feel free to leave them below, but please search for similar questions before doing so. That's it for this video. If you're interested in seeing how you can put your node to use, you can check out the other videos in this series. Thanks for watching and see you in the next one.